Take a look at Andromeda. For billions of years, it has been creating countless new stars. But now, NASA has discovered something unexpected. Hi friends, welcome back to Study Circle Explorer. Today we're exploring our closest giant galaxy, and NASA has discovered something truly fascinating. The answer begins with something we all see every time we look up at the night sky.
When we look up on a clear night, the stars appear perfectly still. It creates a powerful illusion that the universe is a static, frozen void. But on a cosmic timescale, that stillness begins to break down. Entire galaxies actually do grow old. The clearest evidence of this process is happening right next door. At roughly 2.5 million light-years away, the Andromeda Galaxy is our closest giant neighbor, and it's visible to the naked eye under dark skies. It exists on a massive scale. Andromeda contains around 1 trillion individual stars, making it significantly larger and more populated than our own Milky Way. Astronomers have tracked this system for generations.
Before we continue, let's see what astronomers actually discovered, and why this discovery is so important.
Recent observations reveal that Andromeda is undergoing a measurable physical transition, entering a completely new stage of its life cycle. But how does a sprawling collection of 1 trillion stars actually age? And what can that process tell us about the ultimate fate of our own galaxy?
In astronomy, aging does not mean a galaxy is dying or fading into darkness. Instead, researchers use the data to show that Andromeda has simply entered its middle age. Look at the biological-like engine that drives a galaxy. It requires vast reserves of cold gas to act as raw fuel for new stars. But Andromeda's star formation rate has plummeted. Its cold gas reserves have been consumed and aren't being replaced fast enough. Think of it like a booming metropolis. During its early years, a city expands rapidly in every direction. Eventually, it runs out of open land. The cranes come down, and the city settles into a quieter, slower rhythm of existence. This reduction in raw fuel marks a permanent, irreversible shift. Andromeda is leaving behind its chaotic youth and moving into a calm, mature phase of galactic evolution. Measuring the life cycle of something so unimaginably large and distant requires specific methodology. We can't watch a galaxy age in real time, so astronomers have to look at the historical record.
It seems that a massive force is quietening star formation, right at the dense core of this galaxy, where we expected to find millions of young, bright stars.
Operating like cosmic archaeologists, scientists analyze the specific ages of individual star populations scattered across the galaxy to map exactly when major growth occurred. This chart maps cold gas against star formation rates. Tracking this distribution over time reveals a steep downward curve. These data points isolate the exact crossover point where Andromeda exited its active youth, confirming the galaxy is slowing down. If our closest giant neighbor is actively calming down, what does that mean for the inevitable, looming interaction between Andromeda and our own Milky Way? Scientists refer to Andromeda as our cosmic mirror. By studying the mechanics of its aging process today, we are essentially looking into a time machine that displays the future of the Milky Way. The data shows that our galaxy is on a remarkably similar evolutionary track. As our own cold gas reserves deplete, the Milky Way will eventually face its own middle age. The two galaxies are physically bound, linked by an immense, invisible gravitational pull that spans millions of light-years of space.
If you're enjoying this journey, don't forget to subscribe. Every week, we explore incredible discoveries from our universe.
Decades, models suggested that this attraction would result in a massive head-on collision. However, recent observations introduce a more nuanced picture. Factoring in their exact trajectories, the chances of a direct strike are actually lower than earlier estimates predicted. Instead of a violent crash, their interaction is more likely to be a slow, complex, and intertwined evolutionary dance that will unfold over billions of years. It requires us to rethink our basic perception of space. The universe is not a cold, unchanging void where rocks and gas simply float in the dark. Galaxies are highly dynamic, breathing cosmic systems. They process fuel, they grow, they adapt, and they evolve over lifespans stretching across billions of years. Observing the quiet transition of our neighbor reveals the specific mechanics that will determine our own galaxy's fate. The universe is constantly changing, and today we are only just beginning to understand its incredibly dynamic story.
So, Andromeda isn't dying, it's simply entering a quieter stage of its life. And one day, our own Milky Way may follow a similar path. The universe is full of mysteries, and we're just getting started. I'll see you in the next mission. If you enjoyed this journey, we uncover incredible discoveries from NASA, ISRO, and beyond. I'll see you in the next mission. Until then, keep looking up.